Welcome to today's webinar brought to you by MongoDB, CrateDB, Decodable, and GridGain. I'm Stephen Fegg, Director at Database Trends and Applications in Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Unlocking the Power of Real-Time Data and Analytics. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We'll try to get to as many questions as possible later. Now, to introduce our speakers for today, we're very excited to have with us Colby Ng, Senior Product Manager at MongoDB, Simon Prickett, Senior Product Evangelist at CrateDB, Sharon Shea, Head of Product at Decodable, and Paige Roberts, Head of Technical Evangelism at GridGain. Each speaker today is going to deliver a brief presentation, and then we're going to dive into a group discussion. So, without further ado, I'm going to pass the event over to our first speaker today to get us started. Welcome to the broadcast, Kobe.
Great. Thank you so much. So I'll be talking today about the MongoDB perspective on real-time analytics. Before I jump into it, let me introduce myself briefly. So I started my career as a software engineer at Tableau building analytics software. Then I moved to New York shortly after and worked for 3 different startups as a software engineer. Before landing at MongoDB as a product manager. All right, so what is real-time analytics? So real-time analytics is the ability to process and interpret data the moment it becomes available. And this enables your business or application to take immediate action based on up-to-the-moment insights. And why real-time analytics today? Well, consumer expectations have evolved and continue to do so. They expect online experiences like banking, shopping, and searching all to be in real time with immediate feedback and processing. When making a payment, they anticipate an instant confirmation. And when ordering a product online, they expect up-to-the-minute inventory and shipping updates. This shift in expectations has placed immense pressure on businesses to move from slower batch processing to more real-time analytics, where decisions and interactions happen at the pace of consumer demand. So this puts a lot of pressure on businesses to reimagine their data infrastructure and operations. Now, companies are expected to not only capture and process data instantly, but also to leverage it to drive immediate data-informed decisions. Real-time insights are non-negotiable. In a world where even a few seconds delay can impact delivery schedules and operational efficiency, having real-time insights has become essential for maintaining relevance and meeting customer expectations. Real-time analytics enables faster responses to operational challenges such as route changes, weather disruptions, and vehicle maintenance needs. With real-time insights, companies can optimize routes, adjust to on-the-ground conditions, and ensure seamless and adaptive fleet operations, which is critical for maintaining operational efficiency. So our answer to this is 2 products. We have our time series collections, which we introduced just over 3 years ago, and Atlas Stream Processing, which we introduced in the past year. Now, time series collections are optimized for storing and analyzing time series data with an underlying columnar format, which is optimized for storage. And we use state-of-the-art compression algorithms like delta encoding, delta encoding, simple 8-bit compression, and run length encoding. And Atlas Streams makes it easy for you to process real-time data that either comes from MongoDB collections or Kafka. Next, I'll kind of talk about a lot of the common use cases that we see on the field. So preemptive maintenance is something that we see a lot with our time series customers. It's all about taking in sensor data and analyzing behavior in real time. Instead of flying blind and reacting to events, preemptive maintenance helps us take a more proactive approach, cutting down on costly downtime, which boosts efficiency and productivity. And our customers do this with ingesting sensor data into time series collections and often with help from AI and ML, spotting anomalies and predicting issues before they happen. Take fleet management, for example. For a fleet of trucks, tire sensors track metrics like temperature, pressure, and wear. Real-time analysis on this data tells us when a tire is about to go bad and alerts the driver to change it out. This predictive approach means we can swap out tires just before they're likely to fail, avoiding potentially dangerous accidents while getting the most mileage from each tire. With real-time data ingestion and analysis, fleet managers can stay one step ahead and efficiently and safely run their fleet. So a more proactive approach to fleet management leverages IoT and real-time analytics, enables companies to optimize operational efficiency, reduce maintenance costs, and improve safety by anticipating issues before they escalate. So this category of real-time personalization is something almost everyone can relate to, and usually in our personal lives, but more and more in our work. When we look at personalization use cases, we see applications analyzing user clickstream data, what they're doing, what kind of history they have with the app. And this is all to deliver a contextually rich experience that makes interacting easier and drives meaningful impact for both the user and the business. So historically, personalization was slow and pre-computed, often done poorly, making everything feel static, generic, and pretty outdated. But today, it has to be real time. Personalization has to adapt to the actual situation right now, using background info to create the best possible experience. Let's dive into some examples across industries. Most people think of personalization as a customized welcome screen on an online store, but it has many different facets. So an example from banking is, based on my banking profile, they can tailor my dashboard and offer me products and features that are more relevant to me and expanding their relationship with all their customers. Another example from banking is, let's say I'm applying for a mortgage online, and the system can instantly pre-approve me based on the info I provide, combined with my existing profile. And an example from physical retail. So imagine I'm standing in line at my local grocery store, Wegmans, standing 5 feet in front of the meat counter on a Saturday. The supermarket app detects this location and offers me 30% off of Wagyu beef, a deal that's relevant for me right now in this instant, but probably useless 2 minutes later if I move to another aisle. So across all these examples, real-time personalization has a few things in common. It captures data in real time from multiple sources, think clickstream, past purchases, items in your cart, location data, and more. And it processes and combines that data with what's already known about the user, like the profile, similar customer trends, just to figure out what the best offer is. And thirdly, it instantly delivers a recommended product tailored just for that user in real time. So every day, companies are working to build out these real-time personalization use cases to improve their customer satisfaction and generate new business. So thanks. This is the MongoDB view of how we see customers using our real-time products. Thanks. Now I'll hand it off to the next speaker.
Hello. Hi. So my name is Simon Prickett. I'm the Senior Product Evangelist for CrateDB. And in this short talk, we're going to look at what some of the problems are with obtaining real-time insights from your data and how you can break down silos of data and obtain those more efficiently. So we'll begin with, for those of you who aren't aware of what CrateDB is, it's a hyperfast and open source database, and it's optimized for real-time analytics and hybrid search. So by that, we mean both vector search and Lucene-style keyword searching, the ability to combine those with all sorts of other data types. So this webinar is all about unlocking the power of real-time data and analytics. So why does this need unlocking? What's the problem at the moment? So as we see it, traditionally data has lived in a number of places that is appropriate for that type of data, or organizations have evolved a data strategy over time. So you might have started out with a SQL database and put your data in a regular RDBMS. And then you might have eventually grown a need for a search product and started replicating some of that data into there, or putting some of it in there in the first place. Over time, you might find that you then need to introduce a document database because you have document style, less structured data. And also you probably find that with clickstreams or sensor data, time series becomes increasingly important. Each of those have sort of specialized stores. And you begin to see an issue here of how do we analyze all of this if it's in different places? Then more recently, enterprises might have thrown in geospatial data and also started doing AI, so vector encoding some of those data items so that you can perform similarity searches and get insights back to your users in real time or personalize things. So all of this gets quite complicated. And how we see things at CrateDB is it would be good if there was a single place where you could bring all of this data to perform analysis on it in real time. So CrateDB is one place to store all of these diverse data types. It uses standard SQL and it stores data in tables, but those tables can have very dynamic schema. They can include JSON documents, time series, vector embeddings, geospatial data, etc. Part of the ability to get real-time analytics is you need to minimize the latency between ingesting data, so taking it into a data source, and making it available to query. You also don't necessarily know what sort of queries users or systems are going to make of your data. So the way that we handle this is we have an index everything approach. So all queries should hit an index. And the database is also optimized for a mix of concurrent reads and writes at scale. So for data sets that are always in movement, we aim to minimize the latency between receiving data and being able to query it and aggregate it. Increasingly, we also see data that needs to be in a variety of locations for various reasons. So the cloud is, a common place to store all of your data. And if you're a purely web online company, you may be a web shop, that's great. If you're a warehouse or a manufacturer, you might have need for data stored on your premises or somewhere in between. And we also support the deployment of the database in the cloud in a hybrid on-premise solution and on the edge on very small devices. So part of the ability of unlocking these insights is reducing the latency and getting enough of the data near to where the decision needs to be made. But also if you're in something like warehousing or industry and your redundant links to the cloud go down, you still need a sort of subset of that data to make local decisions and to be able to carry on storing things. So let's take a look at how a real-time analytics database can fit into your architecture. So for example, you might have applications. They generally may put events into the database through a cloud gateway on, say, AWS or Google Cloud or Azure. You may also have streaming type events. So web events, they may come in through a stream processing solution such as Kafka. You might have warehouses if you're a manufacturer. Those may contain edge devices that live in the warehouse and have a subset of the data, but also pass through to the cloud. And then you might be running vehicle fleets or have embedded devices such as kiosks or sensors in a road or other types of sensor. Those may talk to your database through an IoT type cloud gateway. And all of these data sources can end up in a database like CrateDB very easily because it mixes all of these different data types. So some of these will be pure time series, a timestamp and a value. Some of these will be documents with maybe complex structure and variable structure. And some of these will be more traditional relational sources. So additionally, you can also pull data into an analytics database from a sort of CDC or change data capture process. So you might have another database that is your system of record, but you might want to pull data from that into something that's more suited for analytical workload. And finally, you might also talk to AI and ML. You might be doing a couple of things here. You might be training models, or you might be taking data from that database, combining it with other data in that database and returning vector representations of it so you can perform similarity searches. All of these things also need to be used by then, once you've got all of this data somewhere, you want an easy way of writing applications against it and visualization tools. And the point of this is so that you can minimize that time to insights and feed those insights back into whatever it was in the front end. So sensors or the warehouse or the vehicle or the web application, so that it can take an informed action with the most amount of data possible in the shortest time to most personalize something, in the case of, say, a web event or a kiosk or something like that, or in the case of something like predictive maintenance, to determine that this thing is going to go down shortly and needs to be replaced, or we've seen a pattern of usage like this before, we need to start up another line in the warehouse, or whatever the industry is. So in order to have something that gets into your data stream and fits easily into everything that you're doing, you're going to need something that supports a wide range of tool chains and ecosystems. So at CrateDB, we handle that through a couple of things: standard SQL support, support for the Postgres wire protocol, so tools generally can connect to the database and put data into it and summarize data that's in there already if you're using something like Grafana or Power BI, for example. And there's also an HTTP endpoint. So if you've got devices that can just talk HTTP, so there may be very low-level sensors, they could connect to the database directly or through some of the gateways, as we showed before. So let's also look at some use cases here for where this might be important. So warehousing is a use case that we see a lot with our customers. People need real-time insights into warehouse activities for staff planning, monitoring where things are, but also things like compliance. So did we handle a food item entirely within the temperature regime that it's allowed to be handled within? What was the time between certain events, and so forth. Similarly, production monitoring. So again, we have customers who produce things like canned drinks. The production of those drinks needs to be monitored very, very closely. The feedback loop needs to be extremely tight so that you can stop or adjust production accordingly. And you may also be monitoring the actual equipment that is doing the production. So is this conveyor belt running hot? Does this trend generally lead to the wheel bearings failing in the conveyor? Should we take the conveyor belt out and replace it? And then if sort of outside of the physical world, an analytics database such as Crate is suited well for things like personalization in the video streaming or web world, where you have billions of events and you want to either serve or stitch ads into specific users, or they're approaching a kiosk and you want to show them something. Or if you're in the financial industry, this might be, for example, a stream of credit card events, and you might be looking for fraud. So certain patterns that indicate fraud. Again, you want to minimize that time between ingestion and the ability to query the data. So with that said, if I can leave you with one thing, it will be, please go check out learn.cratedb.com and you can learn all about CrateDB, and also welcome any questions at the end. So with that said, I'm going to hand over to Sharon, who is the next speaker.
Hello, everyone. Thank you, Simon and Kobe, for the great presentation. I'm Sharon. I'm a founding engineer and head of products at Decodable. So I'm trying to take a different angle for real-time data and analytics for my presentation. I want to really address the challenges, objections, and the future of streaming. And here, streaming means streaming systems like Kafka, kind of systems, and stream processing, and I'll get into the details. So here, if you know stream processing, stream processing, you know it basically processes data as it arrives, and you can produce the results as soon as possible. Popular frameworks like Apache Flink has really made this popular for low latency processing. So when we talk about stream processing, people think about, yeah, it's powerful because it really enables low latency processing. It is scalable. Flink has this built-in distributed system that you can scale up or scale out easily with tons of machines that give you high throughput of processing. It's also correct, as in it has built-in exactly once delivery. So no matter how many operators you have that's distributed across many machines, internally, Flink is consistent and can process data exactly once. It also has event time semantic. So if you are processing your data, it's not only able to process it based on the processing time. A lot of times you want to really look at the analytics based on event time, and Flink is able to give you that level of control. It's also flexible in terms of it has many ways for you to write your stream processing jobs. It has SQL that has a high-level language that a lot of people like. It's easy to learn. It also has lower-level languages like Java or Python for different engineers who are into different type of programming languages, and also the ability to write custom code. So all of this sounds great, right? It has all the characteristics that you want. But what also is true is that for an organization to really adopt stream processing, it requires a house of smart and hardworking data platform engineers. You can see this from a lot of companies like Apple, Netflix, Uber, you name it. All those companies provide all those real-time use cases in their platform. They also have a very big data platform team that's enable their internal users to write those jobs. So what about the rest of the organizations? And when people learn about this, the cost is too high, and a lot of people get into this denial of truth area. Maybe my use case doesn't require streaming. We don't even need low latency. Our question here is, well, but in what case having lower latency or fresher data is bad in any case? So let's say all things being equal, would you really prefer higher latency or outdated data, or you want the other side? Right, let's think about 5, 10, 15 years ago. There is no on-demand rights. You can't really see, there's no Uber on your app. You can see where the real-time location is. When you order food, you can see where your dasher is at. Right now, you don't know when you will receive your order. For people who are managing their store, maybe their customers go to the store and only find out, oh, they don't have the item in stock. You don't like that experience. And of course, content personalization, Kobe already mentioned about it, and product recommendation. All that being said, all these use cases will not be available without real-time data and data processing. Right? So what's the conclusion here? Well, the other side of the group of people will be like, yeah, streaming sounds great. Streaming should just be the default, right? We all benefit from lower latency and fresher data. And in this case, what's not being told is, well, think about the data infrastructure you need to run. You need to have a Kafka cluster, and you need to run all your Flink jobs that's processing your data in real time. And under the hood, you kind of need to orchestrate everything using Kubernetes. You need to run it in the cloud somewhere. That's where the house of engineers come from. And then what's the answer? That's why a lot of companies still don't have real-time processing in their organizations. And just give you some ideas about the complexity here. As I mentioned, Kafka and Apache Flink are the most popular technologies for real-time data processing here. And when you think about Kafka, not only you need to maintain the infrastructure part of it, your end user need to think about, your end user wants to say, I want to set up a topic for my stream, and they need to figure out, okay, what's the partition count do I need to have? And which serialization format do I choose? How do I integrate with schema registry? And on the Flink side, you just want to process the data, and you think about Maybe I just need to write some SQL and that process my data. Everything is great. In reality, you also need to think about, okay, what's the checkpoint interval that give me the maximal throughput and also the lowest resource utilization and make sure my job runs smoothly? What is the rocksdb compaction thread count is ideal in my case. So that's all too low level, and that adds a lot of burden to the application developers. So in summary, we do think real-time data and processing, streaming and stream processing are great, but there's also a whole round of complexity that people need to deal with. That's why it's really what's holding the technology back. So our response at Decodable to this problem is, one, we need to raise the level of abstraction. We should give people the higher level APIs when they think about connecting their data, making their data usable, and process the data the way they want, focus on the business logic. And then we should remove all the unnecessary config, the stuff that I talk about, right? What's the checkpoint interval? What's the number of threads you need to do compaction? The partition count, all that stuff. Because those are too low level and it's very hard for application developers to think about. And last but not least, running Kafka, Flink, Kubernetes, all that kind of stuff, it has a lot of operational burden. And at Decodable, we make it as a service, so users don't need to think about managing the infrastructure. They can focus on the business logic. So quick summary, Decodable is a real-time data platform and it's fully managed. So it's reduces the stack and eliminates the infrastructure overhead. And it's simplified development. By that, I mean, we really spend a lot of time thinking about end user experience. Me as myself engineer, we think about what the developer user experience is like, the level of APIs we offer to the developers, and the developer toolings integrate with different developer toolings, so making their workflow as easy as possible. And of course, running Flink and Kafka and including Debezium I didn't mention, it's a CDC, change data capture technology. Running all that stuff requires a lot of operational maintenance work. And we have a team of engineers who can provide the level of SLA and compliance. So where does the platform fit? It's a little bit different from MongoDB or CrateDB, where there's an ingestion layer and the database is typically the end of the data flow. So data gets into the database and then you can query it. Decodable sits in between systems because we focus on the processing. So in this diagram, you can see there are a bunch of connectors on the left side and a bunch of connectors on the right side. We focus on getting all those data, out from your source data systems, process it in real time, and that's powered by Debezium, Flink, and Kafka, and gets the data ingested into the destination systems. And you can think MongoDB and CrateDB to be on the right. Of course, MongoDB has a CDC support, so we can also ingest data from MongoDB. And on top of that, we offer the high-level APIs. We have dbt integration. We have web UI for users to get started easily. We have command line tools that allow you to have more like a Kubernetes YAML experience. So that's our infrastructure as code solution. And this is all provided by our system as a service. And I'll give you a specific example of how to use Decodable. So this is more you can see as a practical guide of how to adopt real-time processing in your organization. So we have this customer, Drada. So they are a security and compliance company for people to easily manage their, SOC 2, HIPAA kind of compliance. So they have this use case where they have a bunch of MySQL databases across different regions. And in each of the each of the cluster, they have tons of databases. So essentially, they create a database for each tenant. That's their multi-tenancy model. And that's on the operational side, on the left side. On the right side, of course, as any organization, there's an analytical data plane where you want to do all the analytical queries, understanding the behavior of your customers, and do all those reporting and analysis. So they use Snowflake as their data warehouse. The challenge is they need to ingest all of the data across the clusters and across many databases into Snowflake in real time. And keep in mind, all those databases, the databases in the clusters, they have the same schema, because essentially the same tenant will have a set of the same a database with the same number of tables that's shared the same as other tenants. So indeed, in Snowflake, you really want to consolidate all those tables together, because that's easier for analytics. You want to look at all your tenants as a whole. So using Decodable, they were able to easily connect to their MySQL clusters using our MySQL CDC connector. So everything is happened in real time through change data capture. And we map that into Decodable streams. So you can think about tenant A, table A, tenant B, table B, all get merged into the first stream, the table A stream, and so on and so forth for all the data. So there's a union that's happening in this case. And then with our single Snowflake connection, we were able to write all the streams into different Snowflake tables. And they all have all the tenants from different databases into the same table in Snowflake. And this is just the simple use case to get started. It may sound like data replication. Of course, I touch a little bit on the complexity there. There's a union case in here. And I don't have time to go into the details of schema evolution, but as you can imagine, if they need to update the schema of one table, they need to do that for all their tenants. So our system needs to be able to handle all that. And after that, there's a second use case of, for their AI initiative. With all those operational data in the MySQL database, they also want to be able to provide real-time answers to their customers based on all the controls they put into in the database. So in this case, they can simply add another consumer, since we already have all the data in the stream. So it's a perfect pub-sub architecture. So they quickly write some Flink pipelines and process the data in the stream because they are already available in the stream. And quickly they rolled out their AI use case. Just to wrap this up, as a result, this company, Drada, is able to quickly onboard all their data, replicate all their data into Snowflake, and roll out their AI use case with less than 2 months. And of course, it also gains the instant updates, the low latency, as I mentioned about. The cost is lower, and overall operational cost is much lower because you have way less people worrying about the infrastructure, and Decodable takes care of all that. So that's it. And thank you for listening. I'll hand it over to the next presenter.
Thank you, Sharon. Okay, hi, I am Paige Roberts, Head of Technical Evangelism at GridGain, and I'm going to talk to you a little bit about, real-time data strategies. Imagine that. So first off, what are you trying to accomplish? And right now there's a lot of drive to accomplish more and more inside your business to maximize operational efficiency. I mean, everybody needs to do that, but if you're, say, a smart grid, obviously that's extremely important. Everybody needs to respond to change. If you're in e-retail, I can see where that's a bigger thing. Everyone needs to enhance customer experience. We all have to, keep an eye out for fraudsters. But I think one of the things that's driving real-time data requirements forward are the customers. Customers, they can't click and wait 2 seconds, and everybody thinks that's dog slow. I think that's dog slow. So in order to make your customers happy, you want to reduce your latency down smaller and smaller into the millisecond range to where the customer doesn't even notice the delay. And while you're doing that, you're trying to process and analyze more and more data. So that's, of course, making your life more complicated. And then the fact that the data is exploding is not helping. We've created more data in the last 3 years than we've created in all of eternity before now. And artificial intelligence is beautiful. It's a brilliant thing that can accomplish a lot of things, but it is a data hog. It needs you to give it not just all of your data, but all of it curated and transformed perfectly and analyzed ahead of time, and feed it exactly what it needs, exactly when it needs it, and then it can do its magic. Now, customers are driving that acceleration, operational analytics. Everyone is trying to do that, but if you're in manufacturing or power or something like that, that's even more important. Internet of Things and edge computing is blowing up. And in the middle of all of that, we have fraudsters in there trying to steal everything. So you have to stay ahead of them as well. And this it makes this really multi-dimensional, very complex, difficult problem to solve. And previous technologies couldn't do it. So if you kind of imagine what would be the perfect solution to this, maybe, you got to start with a database. It has to store data. But stream processing is also a big thing. It's like you've got to be able to handle that stream processing, data that's in motion, not just data that's at rest. You need to do all that application logic. There's a lot of different kinds, analytics, transactional processing. You have to be able to execute all of the workloads, streaming, transactional, analytics, and do it regardless of whether the data is just passing by or it's already settled. Or if in order to answer the question that you need to answer, sometimes you need both. You need to combine them. And I think that kind of gives you an idea. It's like you've got to be able to integrate also with all of the things you already have. I mean, people's architectures are complex already, and they need to move into real time. And you're not just doing this for your health. Obviously, there's really good reasons for that. And one of them is to enable your advanced analytics, your machine learning, your AI, and just that real-time decisioning that pretty much everything depends on these days. You got to move it all into the sub-second latencies, and scale can't matter. If you've got massive scale, if you've got medium scale, it can't affect how fast you get your answers. So this is the ideal concept. So what is GridGain? Hey, look at that. GridGain is a unified data platform for processing all your relevant data in low millisecond latency at any scale. GridGain's durable, distributed in-memory database is combined with event stream processing and co-located compute. So you get all of those together in a single thing. You can process streaming data, transactional data, you can do analytical workloads, all of it in real time. So that's pretty much the nature of GridGain, but how does it fit into your architecture? Well, the cool thing about it is it slots seamlessly between your data layer and your application layer without impacting either one. Now that's pretty handy so that you can access everything you need to. Relational databases like CrateDB. You can get NoSQL databases like MongoDB. You can do streaming like Kafka, CDC like Debezium. You can snag your data from data lakes, and you can span your clusters across multiple on-prem servers. You can span your clusters on-prem to cloud. You can span your clusters from an Amazon cloud to a Microsoft cloud. That's one of the other cool things I think about GridGain is that it works wherever you need it to work, and it connects to what you need it to connect. It does that transactional processing. It does your advanced analytics, your AI ML. It can even be your system of record, which means it can persist that data on disk, not just do everything in memory, even though it sort of starts out as its foundation as an in-memory database and builds beyond that. But it can do stream processing as well, and that changes everything. And it becomes a really powerful data hub, a central place where all of your data can be processed and analyzed, curated, managed, and fed into the things that need it, like your enterprise applications, your AI machine learning, your BI. And if you need to, you can take all that beautiful data, put it right back into a Kafka topic and stream it to the next thing that needs it, without ever stopping it from being real time, without ever taking it down to being at rest. You can just stream it all the way through. And I think that is an incredibly powerful thing. Now there's some unique things about GridGain. There's a lot of things that solve sort of one piece of the various problems. One of the nice things about GridGain is it's all unified. It's all together. So you get that ultra low latency response at any scale, but you get to process both data in motion and data at rest. And I know I've already said that, but that's like the big thing. It's like the thing, if you only remember one thing, I want you to remember that GridGain can process both data in motion and data at rest at ultra low latency response at any scale. That capability lets you do transactional, forget hundreds of transactions per second or thousands. You can do hundreds of thousands or millions per second. It becomes very powerful for transactional and analytical workloads because it can respond in milliseconds to all of them. That helps operationalize your AI workloads as well. And it does this by reducing data movement, disk IO. A lot of the things that take up the most time are just kind of gone because you're co-locating the data and the compute both in memory. And it does have some robust APIs, and you can certainly use, Java and Python and REST APIs and things like that to make it work. But you could also use standard ANSI 99 SQL. You don't have to learn something special in order to make this happen, because at its foundation, it is an ACID compliant, maximum durability database. So that gives you all that capability in a single thing. And I think that allows you to accomplish the use cases you're trying to do in real time. The things that require real time require all of that together, not as separate individual pieces of your stack that make your architecture complex and lots of moving parts that might break. So you can accomplish real-time risk management. You can get fast, smart decisions, and you can power your AI ML. You can do transactional and analytical. You can go hybrid across various locations. And you can use that as a low latency data hub. I think that's a powerful concept of having a single central place where you can get all your data, regardless of where it originated from. So maybe you can use GridGain, get 1,000 times faster calculation, like JP Morgan Chase did. And I hope you can. I hope you can accomplish some of these amazing things that these real-time use cases are. So thank you guys, and I look forward to the discussion. So back to Stephen.
Thank you very much, Paige, and thank you everyone for those great presentations. So we are going to dive into our group discussion. This first question I think is pretty straightforward. I think it's a good one for us to kick off with. And Kobe, I'm going to let you be our leadoff hitter. The question is, what is the top challenge facing organizations today that are seeking to expand and improve their real-time data and analytics capabilities?
Yeah, I guess I'll speak to like not necessarily what we see in our customers, but what I've seen at previous companies that I've been at that tried to leverage real-time data. But like the one thing is getting rid of data silos to actually get a comprehensive analytical or set of analytical data where you can actually ask business questions about data in your CRM and merge that with your application data. Like unless you explicitly make that a goal, and maybe you're a medium-sized big company, it's going to be hard it's going to be hard when you have all these different teams building with their own different data sources and going in different directions. So I think you have to make it a unique, a very specific goal to eliminate data silos if you want to get more into real-time analytics that blend more than one data source.
Understood. I think that's a good one to, so we've got data silos on the board. Simon, what are your thoughts? Are data silos on your list? Something else?
Yeah, I can only echo everything Kobe has said, but I would also say that part of the challenge is in the data itself. So there's so many different types and structures of data that are needed for good real-time insights. They all come in different flavors. They might be document, time series, it might be embedded in a video stream or images. And in order to do real-time analytics that is truly meaningful, you need insights that take in as many of these sources as possible. So you definitely want to eliminate silos, but you also need to ensure that you have like a really fast ingestion pipeline, because if the data arrives like 5-10 minutes after the event happens and somebody stood in front of a kiosk in a, I don't know, donut shop or something, and you've got some offer that's unique to them, it needs, as somebody said earlier, it needs to happen now, not in like 10 minutes time.
That's a great point, Simon. I would be annoyed if after 10 minutes of being at the donut shop, that's when they sent the coupon, I would have definitely been annoyed. Sharon, what's your viewpoint on this?
Yeah, so I want to talk about, I touched a little bit in my slides already. I think one is the perceived complexity, and therefore then ties into the risk when someone wants to take an initiative of pushing more real-time data and analytics. So one other aspect of it is, what do people do it today? So a lot of batch processing and the inertia is really strong, right? That making people make the change requires the culture and the mind shift when we go to real time. And because the technology is pretty different, so the perceived complexity is, well, all the processing and management, or the data governance, quality and security, everything becomes real time. So there's way less room for error. So that's the risk. So I think that's a lot of like challenges and holdback for organizations to expand and improve real-time analytics or processing. And I think the other side of it is, at the organization, there's always competing of priorities, and AI has been going really strong. So if there are two initiatives you need to push, one is AI and one is real-time, I see a lot of challenges of choosing real-time data, even though, of course, as I believe, real-time is the fundamental layer to provide real-time AI.
Absolutely, and it does seem like there are lots of scenarios where you're going to need real-time to do AI correctly. Paige, you always have interesting takes. I'm curious what you view as the top challenge or challenges.
Well, I think everybody's right. First off, I think data silos and the variety of data and all that complexity, and I want to just build on that. It's like, I think complexity is the big problem. We have data complexity, stack complexity, computational complexity, it's this huge challenge, and it's really sometimes hard to wrap your brain around the problem even. And there's really a single simple solution. And I think that's one of the cool things is that there are a lot of applications right now that solve one piece of the puzzle, but sometimes that ends up just making your stack more complicated. More moving parts, your architecture becomes more brittle, more prone to breaking, and bigger stacks are not necessarily the right solution. I mean, we have these data problems that Colby was talking about. It's like, everything comes from one particular application, and maybe they're separated, and it's really hard to get them all to pull together. And there was a point in time that was all you had to do. It's just this one application. It's like, let's just, process the transactions for this one application and analyze those transactions, and that's it. We're done. And then at some point it became enterprise wide. It's like, okay, now we have to look at all the data across our enterprise and do analysis and figure things out there. And it's like, now we have trading partners. Oh, we have third-party data. Oh, we have Kafka streams coming in. It's like, you end up with this massive complexity of just the data is by itself complicated. So I think that's probably the biggest challenge, I think, to a lot of the initiatives to try to get to real time are just how complex the problem is. And I do agree that, real time is almost like a precursor to AI. It's like, if you want AI, you need to get to real time first so that you can feed it. It's
absolutely, and it wants to be fed a lot of data. Absolutely. Paige, I'm going to let you kick off our next question. The question is, if you had to pick one thing you think organizations need to focus on more overall to improve outcomes in this area, what would that be?
Well, ironically, if the big problem is complexity, I think the big thing you need to focus on is simplifying your data architecture, simplifying your solution so that, instead of a complicated answer to a complicated question, you try to find a single answer that will help at every level. It's got to pull in all your data from all your locations. It's got to, be able to connect everything, live wherever your data is. Hey, I think a single unified real-time data platform might be good, like GridGain. But I might be a little partial on that one.
That's all right. So, Sharon, what is your take on this?
Yeah, so I've seen this many times from our customers. So I think this just works out well. If I have to pick one thing, I would suggest that for organizations to start with a small but focused high impact use case. And usually that's a new use case, right? Like, I think migrating anything off the existing system, that's complicated and that requires a lot of planning. But if you can start with a new initiative saying, hey, this, it could be real-time AI, this new use case, we want to use, real-time data and analytics, and do that by showcase the value, and that will really, ease a lot of people's mind as soon as you can demonstrate the value and start with a new focused, high impact use case, tie that into tangible benefit of real-time data. And then you can build a lot of trust and credibility in your organization.
I think that's great advice, Sharon. Simon, where do you stand? If there was one thing, you would recommend focusing on, one key success factor?
I think, just to back up what everybody else said, keep it simple and focus on a high impact use case are both important, because that's essentially how you're going to find champions and funding to roll this out to other places. I think I'd also add to that, it might sound silly, but like, do something, and whatever the phrase is about sort of perfect is the enemy of progress. So do something, start something, don't be afraid to experiment and play with things. And in some ways do that by, maybe starting a new analytical database and using CDC and tapping into existing streaming and things to fuel that, rather than be messing around in what's actually a production system with things that are unproven, because you don't necessarily know where you're going to go with this. So in short, to echo everybody else, pick something simple, do something impactful, but also don't overthink it before starting something. So do it in a sort of iterative process, because doing something and seeing where you go and prototyping and working forward from that is better than trying to do some sort of big bang introduction. Do that use case, but maybe pick a fraction of it, take a breath once you've done it, and then see where you go from there.
I think that's great advice, Simon. And I like what you said. If you're going to wait till everything's perfect, you're probably not going to get anything done. Kobe, a lot has been said already, but anything you'd like to add or, emphasize here from your viewpoint?
Yeah, I'll back up what everyone else said about kind of picking the right problem. I mean, not all problems need to be solved with real-time data. Making sure you pick something urgent, maybe like, for example, making real-time fleet monitoring, making sure that all your hosted databases are healthy at all times, and building in the systems to alert when they're unhealthy. Focus on one problem that has a burning real-time need, and nail that one use case. Let's say if you're a company that's new to real-time data, just nail that one use case. Just like Sharon said, prove the value of that first. And I think you're going to want to put on the blinders to make sure that you don't take too broad of a technical angle and don't try to do too much. If you do try to do too much, you're kind of more likely to not fully solve the problem you're going after, and make sure you kind of nail the one business problem that you're solving. So I would say, focus on solving a specific business problem is what I would emphasize.
Don't try and boil the ocean, maintain a good scope. Absolutely. Simon, I'm going to let you lead off on our next question, and this is one where I'm curious what your answers are going to be. What trend are you most excited about moving forward? And you can't say AI. I'm just kidding. You could certainly say AI, but why don't you kick us off with this one?
Yeah, so AI is an interesting one because I don't necessarily see that as a trend anymore. It's becoming like table stakes for these things. So what trend am I most interested in? Personally, it's kind of the opposite end of scale. So you can deliver real-time insights to something that is web scale and is like a huge website or whatever. But you can also deliver real-time insights to something like this, which is like a $10 microprocessor that's got a network connection. Because this might, for example, be thrown in the back of a cement truck and be sending you information about the consistency of the cement that you can then use with a tight feedback loop to determine when that truck gets there, whether the cement is good enough for the customer. It goes into the building, and that's quite a safety issue. But you could also, at the same time, use that for sort of, I've spoken already a bit about kiosks. I've got some experience in that level where you've got the customer's full attention for a couple of minutes while they're ordering their coffee or whatever, and they do some personalization on that. So I think for me, the interesting thing is the micro scale in terms of the size of the device or the thing that's running it, but the macro scale in terms of how many of these things are out there and running. Because if something's very cheap, like Kobe spoke about tire pressure sensors, there's 4 of those in a vehicle. There's how many vehicles out there? They're kind of like cheap, not particularly intelligent, but kind of important. So yeah, I'm sort of excited about IoT trends, and AI and everything else backs that up, and everything we've said about having quality data ingestion and quality data backs that up. Because when you're getting down to something like this, it doesn't even have the RAM to load a full JSON document. So it needs a pretty concise, summarized explanation of something from somewhere else that was able to do that quickly.
That's really interesting. I'm glad you brought up IoT, because there's certainly, and I think we're going to continue to see a lot of convergence between AI and IoT. Absolutely. Sharon, what has you most excited?
Yeah, I was talk about the area that's really gaining a lot of momentum, and this is iceberg. This is at the grand scheme, this is the lakehouse architecture in the data analytics world. And we've seen Iceberg getting a lot of success with its open table formats, and that really highlights the need for users to avoid vendor locking. So I generally agree, think lakehouse architecture is a great architecture for people in the analytical data plane. But there's also a pressing need for real-time ingestion layer and making the lakehouse architecture data more up-to-date and queryable. So, and we see a lot of movement here, right? Like you can see Kafka is evolving to be able to output its topic directly into Iceberg format. Confluent is offering a product called Tableflow, and we see Snowflake and Databricks offering their own catalog support. So I think with streaming and stream processing, we can make data lake much up-to-date by offering this real-time ingestion layer and also making the data much quicker to be queryable in the data lake. So I'm paying a lot of attention there. It's definitely one of the trends I'm seeing. I'm super excited about.
I love that you brought up lakehouse architecture, and it does seem like the future is open for that. That's where everything's heading. Okay, Paige, what are you most excited about?
Well, it's funny because I have utterly agreed with everything Sharon said up till now, and now I'm like, the problem with the lakehouse architecture, I'm a big believer in it. I love it, but it has that whole concept of separating compute and data. And what really excites me is the move to real-time everything. I mean, it's pretty much what this whole webinar is about. It's like the idea that every single thing we're trying to do is becoming real-time. And in order to do that, you have to act on data while it's still moving. So if you Kafka pipeline something straight into a REST format, you've lost your ability to do things in real time right there. So I'm spoiled. I will be one of the first people to admit that I'm one of those consumers who gets irritated when applications take, more than a second to respond. So, and I know it's a huge challenge. It's like I've been on the data processing side of things long enough, a lot of years that I don't want to admit, that I'm getting really excited. Real time is becoming the standard for like everything. And when Moore's law stopped making hardware faster and faster, the software had to step up. And the way to get things faster now is to distribute across data systems and have really good software that can figure out ways to make that faster and faster. And so, I mean, the data processing and analysis software is picking up the slack. And that's the space that we're in. That's where the cool revolutions in tech are happening that affect everything. From, it's like if you've got those tiny sensors that are feeding information from 100 different places, you got to have something that's taking that information, figuring out something important, and telling people about it that quick. And that's real time. It's like it's everywhere. And I don't think it's going away. If anything, I think it's becoming more and more almost the norm. It's like if things aren't that fast, then they're too slow. And it's just becoming to the point where we kind of have to go real time for a lot of things. And we're in the space. We're in the right space for that. So that's cool.
I love it. Real time or the real time way or the highway. And yeah, we've become spoiled and impatient. We want everything right away. Colby, what has you most excited?
Yeah, I'll piggyback off of Simon's excitement about IoT. Along with kind of because AI is so big and vector databases have been all the rage the past 2 years since ChatGPT came out. I think those two combined, like IoT and vector search, kind of gives us the ability to like fuzzy match certain things and match patterns in more abstract ways. I think the application to healthcare is is super exciting. I mean, healthcare is kind of an industry that hasn't really, only now you kind of see a lot more innovation in healthcare with all the wearables, and we're getting better at interpreting all the telemetry that you can get from various wearables like glucose monitors and pacemakers. So I think, and we're only now kind of learning how to, like make some fuzzy diagnosis based on AI with some degree of accuracy. But I think that now that we're actually it's actually hitting the industry and making a lot more headway in that space. I think there's an exciting future for kind of a lot of real-time diagnoses, real-time monitoring of your health, figuring out, like building the muscle of understanding how to take in the noisy signal of your body telemetry and taking that and constructing actionable feedback for you so you can live a healthier life. So I think ultimately, like, that's a very impactful personally, and it's a very, very concrete application of how real-time analytics can help you live a better life and hopefully longer and healthier.
Absolutely. I love that you brought that up. That is really impactful, and that's certainly something everyone can get behind. So we have gone way beyond the bell on this one, but the students are still in their seats, so I'm going to take advantage. Lightning round. Sharon, we're going to start with you. If there's one thing you'd like our attendees today to walk away keeping in mind, what would it be?
Yeah, I think it's really about, we talk a lot about, hey, the complexity is high, and maybe people think running real time, the cost is high. I think being able to like break that down into different cost profile or complexity, right? Like in terms of the cost, I like to think about the infrastructure costs, the development costs, and the operational cost. And once you break that down and do the math and use, with all the modern services provider that are usage-based billing with auto scaling, all that kind of stuff, you will quickly come to the conclusion that, okay, the development cost is low because with higher level of APIs, operational cost is low because there's a team that's managing this for all of their customers that has economy at scale. So I hope at least that changes people's minds. The complexity and cost is not that high when you do real-time data and analytics.
Understood. Great point. All right, Paige, you are next. If there's one thing you'd like our attendees to walk away keeping in mind, what would that be?
Okay, this time I'm going to say what she said. I think Sharon is absolutely right. You think of a real-time project as really complicated and really difficult, and it can be simple. It can become something that's not that expensive and not that hard. And a lot of it is just getting the right technology in there and getting the right buy-in from the right people. So you combine those two things, and you can end up with a fairly simple real-time architecture. It's not that hard. It really can be done.
All right, words of encouragement. I like it. Kobe, what about you?
Yeah, I mean, I guess one thing, focus, relating to all my previous answers, focus on solving the right business problem. So focus on solving that business problem first and let the technology follow. And like everyone just said, it doesn't have to be complicated. I would start with, I wouldn't look first to add a bunch of new real-time technologies, but just take a look at what you have around you, see how far that can get you. And only if you absolutely don't have, let's say, the proper data latency, then I would say look around for other solutions. But attempt to simplify and make sure you solve the right business problem.
I think that's good advice as well. Simon, we're going to end on you. If there's one thing you'd like everyone to walk away keeping in mind, what would it be?
So everything everybody else has said, and I guess from a people perspective on that, encourage people to do it. Encourage a culture of experimentation. In some ways, when we created CrateDB, it was partly because you want to put any sort of data in there and query it without necessarily knowing when you did that what the sort of queries were going to be. So encourage people to start these projects. As we said before, they don't have to be done to be, or they don't have to be perfect to be done. It's an ongoing learn. And also enable people, don't gatekeep this stuff. So enable tools to produce visualizations and query these platforms and databases to as many people as want them. Don't silo it down to, oh, you have to be a data scientist to do this, because ideas can come from anywhere. And if you've got an appropriate sort of analytics platform, people should be able to, pummel it all the time without affecting anything in your real production world. So let them do it.
I think that's a great point. Well, you all made my job very easy. I'd like to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise. Once again, Colby Ng, Senior Product Manager at MongoDB, Simon Prickett, Senior Product Evangelist at CrateDB, Sharon Shea, Head of Product at Decodable, and Paige Roberts, Head of Technical Evangelism at GridGain. So if you in attendance would like to review this presentation or send it to a colleague, you can use the same exact URL that you're using right now. This will be archived, and you will receive an email once the archive is posted. Thank you, everyone, for joining us today, and we hope to see you again soon.